Okay, so here comes another video about differentials off of the review sheet. Okay, so what we should remember about differentials is that to find them, use f of x equals f prime of a times x minus a plus f of a. And looking at example B, we're trying to find sine of pi over 20 using differentials. So we need to go ahead and identify the elements of the equation up above. So we should know that the equation, or the f of x, is sine of x, and go ahead and take the derivative of that. So f prime of x is equal to cosine x, and our x, which is the hard one we're trying to find, is pi over 20, and a should be the easy one, and that is 0. So going through, we have sine of pi over 20 is equal to our f prime of a, which is cosine as far as the derivative, and a is 0. So we have cosine of 0 times pi over 20, which was our x, minus 0, which was our a, plus the sine of 0, which is our f of a. Okay, so whenever we plug all that in, we get sine of pi over 20 is equal to 1, which is the cosine of 0, times pi over 20, which you get from pi over 20 minus 0, plus 0, which is the sine of 0. So then, whenever we get that, 1 times pi over 20 plus 0 is equal to pi over 20, which is approximately 0.157. And whenever we actually take the sine of pi over 20, that comes out to approximately 0.156. And we see that those are really close, so it checks out. Differentials, and the example C, we're trying to find the ln of 1.2 using differentials, which our equation is right up there. So when we identify our function, our f of x is equal to ln x, and whenever we take the derivative of that, we get the derivative is 1 over x. So now that we know our x is 1.2, which is our hard one, right over here, inside the parentheses, the 1.2, and our a is going to be 1, which is our ln of 1.2 is equal to 1 over a, our f of x. Just substitute the a in, so we have 1 over 1 times 1.2 minus 1, and there you can see our f prime of a is 1 over 1, x is our 1.2, and our a is 1, plus f of a, which is going to be the ln of 1. Plus our ln of 1, which is our f of a, and that is equal to 0. So from there we have 1 times 0.2 plus 0, which gives us 0.2. And if we actually use our calculators and do the ln of 1.2, we see that that is approximately 0.18, and we see that those are really close, so it checks out. And congratulations, I believe it's Newton's method next, so tune in and have fun.